Half-life problems should be modeled with an exponential relationship. And f of t represents how much you have left over after a certain amount of time. K represents how much you start with of an element. A represents some sort of rate for the exponential change of the element, and T represents time. So the big thing about these half-life problems is you need to find out A before you can usually answer their question. And all you need to do that is take this first part. Half of an element is left after 30 years. It doesn't matter how much you plug in for K in here. If you plug in 4, half of 4 is going to be left over when you plug in 30 years in for T, because that's what half-life means. Start with 4, half of it's going to be left after 30 years. But every time you plug in a number, whatever you want to plug in for a starting amount, you're always going to get this on the left side, 1/2. So after a while, you'll see a shortcut with how you can just jump to saying 1/2 equals A to my half-life time, 30 years. So we can finish solving for A. And just a quick note, look, we didn't do anything with any of the other stuff yet, okay? We're just finding out A because we need to know that to answer their question. We can finish solving for A by raising both sides to the 1/30th power. Because a power on top of a power multiplies. 1/30th times 30th gives us A to the first. So we need a calculator from 1/2 to the 1/30th. I did some rounding for A. But now that we finally found out what A is 0.97716, we can plug in the information that they asked for in this problem. They give us a starting amount of 10 grams. Multiply that by the A that we found. They want to find out how much is left over after 27 years. So we'll plug that in for where it's supposed to go in for time. And so when you plug and chug this with a calculator, it will tell you how much is left over after 27 years. When you plug that through your calculator, you should get 5.36 grams.